Hello geometers, we're going to talk about the congruence postulates and theorems for triangles. We have the side angle side, the angle side angle, side side side, angle angle side, side side angle, which is neither a postulate nor a theorem. I'm going to show you why it doesn't work, and the hypotenuse-leg, which is only for right triangles. So let's look at the first one. Side angle side. What that means is if the side and the angle on the side of one triangle are the same as they are for another triangle, and here's how I know that they're the same. It's because I traced them off of one. So here's another triangle. And can I show that, is there any way to finish that triangle so that it's not congruent to the original triangle? Well, all I can do is connect the endpoints, so I think you can see that that's going to produce the original triangle. And when I pick that up and put it on top of the original triangle, it's the same triangle. That is not a proof. That's only a demonstration of what we mean by side angle side. Let's do angle side angle. In angle side angle, we have an angle and two angles and the side that's in between them. Two angles and the side that's in between them. So I've copied this angle and the side and the other angle at the end. But notice I haven't extended the angle up. Is there any way to, with those parts, to complete this triangle and not come up with the original triangle? So let's try and see what happens. I'm going to have to extend this side to make it long enough to meet up with that side right over there. And so that's what I'm doing here. And then on this side, that angle right there, I'm going to extend that line, that side of that angle, and when I pick this up and put it back on the original triangle, it's the same triangle. What was that? That was angle, or angle, side, angle. That was the angle, side, angle. That's also a postulate. The next one is side, side, side. So here I have three parts of triangle that I have copied off of the original triangle. I'm just going to stick them up there and see if I can fit them together in any manner that will not be the same as the original triangle. And this piece would be, is it that one? That's a little short. Okay, yeah, it's that one. So I'm going to stick that on this triangle here. I'm not trying to copy that angle. I'm trying to see if I can disprove this theorem somehow. All right, here is the third side. Yep, that's the third side. So let's see if I can fit these sides together in such a way. Well, clearly that's not going to meet unless I bring this angle in, that side in. That's a pretty good match. This is a demonstration, that's not a proof, so that when I pick that up and put it on top, it is, well, it's because I've got the ends a little bit funny. But side, 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 if we did it with a compass and a straight edge, you would see that it would produce exactly the same triangle. The third, or the fourth one is angle, angle, side. So, let's see. Which means I've got an angle and a side. And I don't know if that side's long enough or not. Let's find another angle, which would be this one. Okay. And what I'm going to do is extend, let's see, I think I need to measure to see if that side is the same length as my original side. It looks pretty close. Okay. So I need to extend this length right here until I can fit this angle on there so that it matches up with the end of that piece right there. Okay, there we go. And you can see that those two triangles are the same. That's the angle side. Here is the side angle, and this is a demonstration of why it doesn't work. So what I have done is copied the angle and the side, and I want to stick on a side. I want to extend that angle, first of all, and then stick on that third side. And here's the third side. Okay. It looks like I need to extend my angle just a little bit more. And here's the third side. Well, if I stick it on here and stick it up there, it does indeed look like that triangle. But remember, I don't know what this angle is. Here is another triangle that satisfies side angle, and it is not congruent to that triangle up there. So side angle is not a congruence theorem. The last one is for right triangles. Only, and so we'll take that off. Here is my given right triangle. Here's my given right triangle. It's got a right angle indicated there. This piece should match the hypotenuse. It is the same length as the hypotenuse. And then I have a leg piece that matches the leg piece. And notice I didn't extend that side, but except long enough to just include the right angle. Can I stick that hypotenuse on this leg in such a manner as to come up with a different triangle? Let's move things over a little bit here. So here's my hypotenuse, and there's a leg. Let's see if I try it real skinny. But I need my hypotenuse to be that long. So let's do this. Let's lay this hypotenuse on last. Go ahead and get our legs of my right triangle laid out here. So I'm going to extend that side right there. And we wanted this piece to be the same as that piece. So that's the leg, and here's the hypotenuse. And since it's a right triangle, it's got to have a right angle. Now, where can I fit this hypotenuse on here so that it meets up with the other leg of the triangle? It's got to go right about there. Now compare that with the original triangle, and they are congruent. So that's the 5 congruence postulates and theorems, and a demonstration of why the side angle cannot be used to prove congruence.